In this video, we'll see how to solve this predicament problem. So we are given an array and we have two players, player 1 and player 2. Each take turns. So player 1 has the array. He can either choose from the either end. He can either choose the first element or last element. So once he chooses, let's say he chooses the first element, this is the remaining portion of the array, and player 2 has to choose from this array. He has to choose again from one end of the array. So, and player 1 gets the first turn. We have to return whether player 1 can win or not. So if player 1 can win or he can tie the game, we need to return true. If not, we need to return false. Let's assume that solve is the algorithm. If given bounds, it gives the maximum score that a player can achieve, and both players play optimally. I mean, both are equally talented and both can use this algorithm. And yeah, so as player 1 gets the first turn, he can either choose from 0 and n-1 if n is the size of the array. For generality, let's say player 1 can choose between I and j. Alright, so player 1 wants to win, so he wants to minimize the maximum score that player 2 gets. Okay, so he wants to minimize the maximum score that player 2 gets. So what player 1 does is he checks which combination or which possibility gives player 2 more score. Either if player 1 chooses I, player 2 gets the interval I plus 1 to j. If player 1 chooses j, player 2 gets the interval I to j minus 1. Player 1 uses the algorithm and checks which of these combinations, whether this gives more score or this gives more score to player 2, and he finds out. So if he finds out this combination is giving more score to player 2, he'll try to avoid this combination by choosing j. So if player 1 chooses j, this combination is not possible, right? So let's say I plus 1 to j interval is giving more score to the player 2 than this interval. So player 1 chooses j. Okay, so player 1 score, it chooses j, and this is avoided. So player 2 has to choose from this. Okay, player 2 has to choose from this, and what is the if player 2 chooses from this in such a way that it gives whatever the interval is remaining for player 1, it gives the minimum score. Let's say if player 1 chooses I, then the interval remaining for player 2 is I plus 1 and j minus 1, right? If player 2 chooses j minus 1, then the interval remaining for player 1 is I j minus 2. And we know that player 2 also chooses in such a way that he gives the interval with the least score. So whatever is the least scoring intervals among these, that is given for player 1, and that will be added to the player 1 score. So basically this is the algorithm. Okay, so let's see the code. So from here, what we're trying, we're calling this solve algorithm. Solve algorithm gives the, as player 1 is calling it, he'll get the player 1 score, and these are the base conditions. If I equals to j, then there's only one element, we'll return that element. Or if the left interval cross the right interval, it means we don't have an interval anymore, and we return 0, and we'll get to this part later. And here player 1 is trying to check which interval gives more score. So let's say if this interval gave him more score, I plus 1 to j, then as shown here, we are trying to this, player 1 tries to avoid this interval. Player 1 tries to avoid this interval from being used by player 2 by choosing j. So if player 1 chooses j, then player 2 cannot use this interval. Player 2 can only use this interval. And player 2 will choose one among I or j minus 1. What does he choose? If he chooses I, player 2 gets the interval I plus 1 j minus 1. If he chooses j minus 1, player 1 gets the interval I j minus 2. What is the value he chooses? It'll in such a way that like player 1 will get the minimum among these intervals, because player 2 is also playing optimally. Let's say this interval is greater, then we'll do the other way. If this interval is beneficial for player 2, we'll try it. Player 1 will choose I, hence player 1 cannot get this interval, and player 2 only gets this interval because player 1 choose an I. And if player 1 chooses I plus 1, if player 2 chooses I plus 1, player 1 is left with this interval. If player 2 chooses j, again player 1 is left with this interval. And player 2 chooses such a way that player 1 gets the minimum among this, so we take the minimum and we add this as the score. We are adding a little bit of memorization here. Instead of solving the intervals every time, if we solve the interval once, we keep this in the memorization interval ij, and if it's not 0, we just return it just for memorization. And now we have the P1 score. Here we have the sum of the total interval, and if P1 score is greater than, so sum minus P1 score is P2 score. From the total sum, whatever score P1 has got, if we subtract that, we'll get the P2 score. If P1 score is greater than or equal to P2 score, then P1 has won. So then we return true.